Hi everybody, I'm going to show you how to do a nice little activity using a graphing calculator that puts all the stuff we talk about graphing into play in a nice condensed version. So if you don't have it already, get your graphing calculator and we're going to show you how to use it in ways you haven't done maybe in a while. Also, you want to have that reference sheet that's attached in Schoology that tells you how to plot points in a graphing calculator, how to get an equation, and how to find slope. Okay, so I'm not going to do that right now. I'm going to trust you know how to do that. I'm just going to point out what the goal of the exercise is by taking you through two examples. All right, so I'm going to do data set 2, and then on the other side I'm going to do data set 3. The others you're going to try on your own. What you're going to do is for each data set you have a x variable and you have a y variable. In this case t and v. T and it has units seconds and v is meters per second. You don't have to necessarily know what they stand for, but it's time and speed. And I've also put up here L1, L2, which will help you with the first few for the graphing calculator, and then you can learn from yourself. So what you want to do is you want to go to your list. I think it's like stat edit, and you want to enter this data in L1 and you want to enter this data in L2. So go ahead and do that now and then restart this once you have entered the data in those columns. So once you've entered that data, you can now plot what that data looks like on a graphing calculator. And again, you can follow the instructions on the other sheet on how to do that. If you do it correctly, okay, so let's go up to these axes. So what you want to do is take this data and show what the graph looks like. You don't have to actually plot the points, but the shape of what it looks like. But first we have to label our axes. So if this is L1, that means time is here, t, and then v is here. So make sure that your axes are labeled. If you plotted the data correctly, okay, you should have a line that looks like that. So I'd want you to sketch that. And that's what our goal is to ultimately make an equation from a line. Since this first graph is linear, I don't have to do anything with this because I don't need to linearize it. So next you want to do is come up with a mathematical expression. In order to do that, you need to find the slope of this. Okay, so again, that can be done on your graphing calculator fairly easily. Follow the instructions. Once you have that slope and y-intercept, and ideally your y-intercept should be close enough to 0 to be 0, is I want you to make an equation in here. And I want that equation to be in terms of the variables given, v and t. So you're going to use the generic, as a frame, a template, the generic y equals mx plus b. But I don't want to see y or x anywhere in that mathematical expression. So if we use the generic y equals mx plus b, you ask yourself, what's your y variable? Put it there. What's your slope? Equals, put it there. What's your x variable? Put it there. And then if there's no y-intercept, leave that blank. Okay, so you should be able to come up with a pretty straightforward equation based on that first graph. The next one is a little bit more involved. So let's go to this one. So we have v for our x variable, so that's L1, and we have p for our y variable. And we can see right away that this is not going to be linear because as v gets bigger and bigger, as we go down this way, p gets smaller and smaller. So hopefully that triggers in you one of the graphs that you saw from your notes. You should anticipate what the shape is going to be. But once again, you're going to clear your data from the previous exercise. You're going to enter this data in L1. You're going to enter this data in L2. And then graph that data and sketch the graph right here. So again, label our axes. V is down here. P is on the y-axis. I want to see what that shape is. I'm not going to tell you what that shape is. Well, actually, I'll walk you through this one, but I want you to go through it and convince yourself. So that shape should be a graph that looks like that, an inverse. So we want to take that and make that a line for the second set of axes so that we can make an equation down here. So this is where you use that linearization idea. What is this graph showing us, this inverse, proportionally? What it is saying, and based on a shape, the generic shape of an inverse is y is proportional to x. Sorry, the generic equation. So translating that to this particular situation, we can say our y is p, and we can say it's proportional to 1 over v. So that gives us a clue as to what we need to graph in order to get a straight line. So I take my p, I want to put it there, and I want to plot 1 over v right here. In order to do that, I gotta get rid of this data in L1 and put in 1 divided by 0.1. So 1 divided by 0.1 is 10. 1 divided by 0.5 is 2, and so on and so forth. Such that when you graph this, you should get a straight line. Then you need to find the slope of that straight line. You'll get a number, and now you want to translate that in an equation. So again, we're using that y equals mx plus b template, where y is this, m is your slope that you get from your graphing calculator, and then x is not v, but it's 1 over v, because that's what we plotted on the x-axis here. So you should look, what it should look like is p equals some number times 1 over v, and that's your equation. Okay? So the rest of these, I want you to do the exact same thing. If it's linear, make an equation right away, and then you don't have to do anything here. If it's nonlinear, it looks like this, then you have to do something here, make it a line, and then come up with an equation. Good luck with that, and then eventually I will put a solution key as a link.